Hi, and welcome to the Module 4 study guide. This is going to be a doozy. Let's get started with the first question. And it says, I'm going to zoom in here. A printer can print 130 pages in 40 minutes. Write a ratio that can be evaluated to find the unit rate per hour. There's a couple ways to do this. I'm going to do this on the separate sheet. So number one will be, so it's 130 pages per 40 minutes. So let's find how many in 1 minute. And for that, it would be, let's divide it by 40 to find the unit rate. And that would be 130 divided by 40. My calculator's right here. And it would be 130 divided by 40. And that is 3.25. So that is 3.25 per one. So that's 3.25 pages per 1 minute. And you might think that you're done at that point, but you're not, because it says here, you have to do it per hour, not per minute. And that's what we have. So we're going to have to, if that's for 1 minute, then we have to multiply it by 60 because there's 60 minutes in 1 hour. So I'll just take times 60 minutes, and that would, and it could be 60 minutes per 1 hour. And what's kind of cool about this is the minutes can cross cancel right there, leaving you with the unit of pages per hour. See that? Pages per hour, which is exactly what they want in here, the unit rate per hour. And so we simply take 3.25 times 60. 3.2, I already have 3.25 here, so times 60, and that's 195. That's 195 pages per hour. I'll box that. Okay, number two. I'll just have it ready here. Number two, and which speed is the fastest? So I have 22 feet in 18 minutes. So I have A is 22 feet in 18 minutes. Oh goodness, let's find how many feet in an hour. Okay, so let's find feet per 1 minute and then multiply it by 18. So let's do 22 feet, feet, ugh, oh my God, feet in 18 minutes. Divide these both by 18. 18 right there. And that will be, well, in the denominator, it'll be 1 minute. And so when we divide this right here, it'll tell us how far do we go in 1 minute. So 22 divided by 18 is 1.22. Okay, so that's 1.22 feet in 1 minute. But I said let's do it per hour. So let's multiply this by 60 minutes is 1 hour. And so the minutes will cancel, leaving us with feet per hour. Feet per hour. And 1.22 times 60, I already have this here, times 60 is 73.3. 73.3 is fine. So 73.3. Okay, so that's the first one. We have to do this for all of them. So 6.5 feet in 4.5 hours. So we already have it in hours there. So B is 6 feet, 6 feet in 4.5 hours. So I'll just say 4.5 hours. And let's just divide that out. 6 divided by 4.5 is 1.3. So that's 1.3 feet per hour. So now we're comparing. We know that if you go 73.3 feet in 1 hour, that's going a lot faster than just going 1.3 feet in 1 hour. So far that's the winner. And then we go on to C. C is 2 yards in 1.5 hours. So 2 yards in 1.5 hours. What you have to know is yards and feet. We have to turn these 2 yards into how many feet that is. Well, I'll star this here. 1 yard equals 3 feet right there. So that means that 2 yards equals 6 feet. And so there we go. 2 yards is 6 feet. So that means I'm going to turn this 2 yards into 6 feet in 1.5 hours. 1.5 hours. Now, just like this one, we're going to divide this here. 6 divided by 1.5. 6 divided by 1.5. It's 4. That's it. It's equal to 4 feet per hour. So we're comparing 73.3 to 1.3 to 4, and this is still going way more feet per hour than any of the others. And then we look at D. And D is 1 2/3 yards in 15 minutes. 1 2/3 yards in 15 minutes. So what did we do here? The relationship between yards and feet is you multiply the 1 times 3 to get 3, the 2 times 3 to get 6. So to turn this into feet, we have to multiply this by 3. So 1 2/3 yards times 3. That will tell us how many feet we have. So let's turn this into an improper fraction. 3 times 1 is 3, plus 2 is 5/3 times 3 over 1. And that is, you multiply across. 5 times 3 is 15, and 3 times 1 is 3. So that means it is 5 feet. Okay. So 1 2/3 yards is 5 feet. So there we go. Now we have feet. We have 5 feet uh, in 15 minutes. So in 15 minutes, divide them both by 3. I'm sorry, divide them both by 15, right? 5 divided by 15, you can use this here. 5 divided by 15 is 0.3. I'll go 0.33. 0.33 over 1. And so that's in 1 minute right there, but we want 15 minutes. And I pause for a moment because, I'm sorry, no, we want it for 1 hour. I was wondering what. Okay, so this is 0.33 feet in 1 minute. So then we have to multiply this by 60 minutes over 1, right? And so it's really just 0.33 times 60, because this is 1 minute. Say 1 minute, and that's for an hour. So 0.33 that I already have in here times 60 is equal to 19.99. Equals 19.99. What? Feet per hour. And now we have this whole thing now. I'll zoom out a bit, and we have A was 73.3. I will, I wonder if I have a highlighter. I don't really have a highlighter, do I? Yeah, I do. So we're comparing this value to this value, and this value, and this value. So the biggest number is the winner. And that certainly is still our A option. So this is the answer. A is the answer for that because it goes the most feet per hour. Okay, number three. Number three, what is the unit price for a piece of cheese if 1.35 pounds costs $12.65? This one's going to be a lot easier. This is just price per pound. So it's 16, not 16, it was 12.65 divided by 1.35. And that's right there, these two numbers right here, price per pound. And so I take 12.65 divided by 1.35 divided by 1.35, and that is 9.37. We stop at the 7, so that equals $9.37, right? Because we don't need the rest of the decimal, because when money, we stop at the penny right there at the 7. Uh, dollars per pound. And I'll box that. That's number 3. Number 4. Which table shows a constant rate of change? Okay, so what I'm going to do for this one is I'm going to write for number 4. It's really the y value divided by the x value. So 179.2 divided by 7. 179.2 divided by 7, and that's going to equal something. And then 358.4 divided by 14 equals something. So I take that number divided by that number, and then I'm going to do 537.6 divided by 21. 537.6 divided by 21. And that's all going to equal something. So let's go 179.2 divided by 7 is 25.6. 25.6. 358.4. 358.4 divided by 14. Oops. Oh my God. I didn't notice. 358.4 divided by 14 is 25.6 again. And then 537.6. 537.6 divided by what? 21 is 25.6. The fact that y divided by x is the same all the way through makes A the answer. Well, let me show you B real quick. If I have B, we have what? 179.2 again. 179.2 divided by 7, that is 25.6. And then the other number is 344.4 over 14. So 344.4 divided by 14, and I'll do that. 344.4 divided by 14. 24.6. 24.6 is that. So this is 24.6. And the fact that these are not the same number, that's what you're looking for. That B is not the answer. A is the answer. And so if you were working through the whole thing, then you would work through, y divided by x all the way through. Number 5. Where is it? Number 5, a student spends the same amount of money each week on lunch. 3 weeks, he spends $84. Write an equation for this relationship. Let x be the number of weeks. So let's look at number 5. I'm going to write number 5 over here. So number 5. A student spends the same amount each week. In 3 weeks, he spends $84. So x is the number of weeks. So x is the number of weeks. So he spends the same amount each week. Well, it begs to see. Well, let me check here. If I have 3x 3 times x is 84. X is the number of weeks. Yeah, that's not going to work. That's not it. Because if he goes for 2 weeks, 3 times 2 is 6. That's not 84. Or 3 weeks, 3 times something. So this is not it. What we need to do is we need to go x is the number. So x will be 84 divided by 3. That would be it. And so 84 divided by 3. 84 divided by 3 is 28. So which is 28. So I guess this technically is an equation, but they're probably looking for this. 28 times x is equal to 84. And that would be the equation. I guess technically, yes, that's an equation, but this is an equation that you would solve for x, and usually that's what they're looking for here. And how did I get that? Well, I took the amount of money divided by the number of weeks, gave me how much money it was per week. And so now 28 times 3, I already know, will be 84. Number 6, draw a line through the points. Why does this line show a proportional relationship? Um, I would say, um, first off, let me draw a line through the points. And I think I'm going to be disappointed here because it looks like I biffed it here. It needs to be a straight line that goes through the origin, which is 0, 0. So maybe I should say, I mean, this is not a proportional relationship. So maybe I should say, why is this line uh, not show a proportional relationship, right? But first off, it's not curved. Well, that's true. It's not curved. It is a vertical line. Well, a vertical line, that's a straight up and down line. Like that's vertical. If you go side to side, that's called horizontal. So it's a vertical line. No, it's not a vertical line. Uh, it connects all the dots. I guess it does connect all the dots. Does it go through the origin? In this case, it's false. It does not go through the origin. So that's why it's not a proportional relationship. So a little confusing. Sorry about that. Um, what is the constant of proportionality for the relationship on the graph? Well, it doesn't officially have a constant of proportionality because it doesn't go through the origin. I really biffed it on that. I thought I was really being very careful about it. But the constant of proportionality is usually the y value over the x value. I guess if I were going to do this, it'd be 5 over 2 because we would take the constant of proportionality would be the y value over the x value, which we can see here that it hits 5 and 2. So I guess 5 over 2. And so the constant of proportionality um, for number 7, the constant, which is often called k, is the y value divided by the x value, which I'm calling 5 divided by 2, which is 2.5. So I guess in all of these, it would be none because none of these is 2.5. So I would call it B. Oops. But in the test, I would definitely make this a proportional relationship, and I would make sure that it was a y value over the x value right there, and it would be a straight line. If the next one, 8, if b is an integer, when is a over b never equal to an integer? Aha, this is good. I like this. I'm going to keep going with this here, and I'm going to, oops, I just drew right through my line, right through my 6 right there. I killed it, but didn't mean to do that. But anyway, I have number 8. And when is a over b never an integer? So when is a over b not an integer? Well, the answer is when b is equal to 0. Uh, so take an integer. Like an integer is all these positive and negative numbers. Like integers are those numbers on the number line where integers are these numbers lines like 0, 1, 2, -1, -2, and so on. These are all integers here. So when is this not an integer? When b is 0, because take a number like 5 divided by 0. What is 5 divided by 0? You don't want to say it's 0, but it's not. It's actually called undefined. You can't divide by 0. You can take 0 divided by a number, and that's 0, but if any number divided by 0 is undefined, it's an error. You can't look at this. Look at this. If I do in a calculator 5 divided by 0, if E, I know it says 0 there, but there's an E that shows up. Okay, that means there's an error. That means you can't do it. So it is A. Number 9. Number 9 on the other side. So complete the table for an object that goes 1/4 mile in 5 minutes. So 1/4 mile, this is going to be 5 right there. So number 9, 1/4, it goes in for 5 minutes. Ooh, I just saw something here. That's 1/4 mile. 5 minutes is how many hours? So that's going to be uh, miles, and this is going to be hours. Oops, miles and hours. So 1/4 mile, and then it has 1 1/4 mile and 2 1/4 mile. So uh, that's 5 out of 60, right? That's 5 minutes. 5 minutes out of 60. Okay, that's what it has to be. So let's see. How many times does 1/4 go into 1 1/4? How many of these fit in here? Uh, I guess what I could do, I mean, it's 5, right? Because I already know that 5 1/4 fit into 1 1/4. So I would have to multiply this by 5. And 560 times 5. So I would have to say 5 out of 60 times 5, which is the same thing as 5 over 1, is 25 over 60. So this would be 25 over 60. Okay. How many 1/4 fit? How many 1/4 fit into 2 1/4? Well, 8 1/4 fit into 2, plus one more is 9. So this is going to be times 9 right there. So I have to multiply 5/60 times 9. So for this here, this would be 5 over 60 times 9 over 1, which would be 45 over 60, which is, yeah, I won't even put it in there. So what are those missing values? 25 over 60 and 45 over 60. And maybe I'll put that in here. So this is 5 over 60. This is, what did I say, 25 over 60. And then this is 45 over 60. Okay, number 10. If a person bikes 1.6 miles in 4 minutes, how far can he bike in 1.5 hours? Um, okay, then 1.6 miles, 1.6 miles in 4 minutes is how long, how far per minute? Yeah. How far per minute? So this would be divided by 4. So 1.6 divided by 4, 1.6 divided by 4 is 0 0.4. So 0.4 miles in 1 minute. Okay. So we need 1.5 hours. 1.5 hours equals, isn't it 90 minutes, right? Because 1 hour is 60 minutes, and a half hour is 30 minutes, and 60 plus 30 is 90. And that's 90 minutes. So we need to multiply this by 90 minutes over 1. Minutes will cancel. And it's really just 0 0.4 times 90. 0 0.4 times 90 is 36. 36 miles. Okay, number 11. Explain how to simplify this complex fraction. Interpret the meaning of the result. Okay. Uh, so divide 3/112 by 3/4 using keep, change, flip. Uh, interpret the meaning of the result. So we have to find the result. So what is 312 divided by 3/4? That's 312 over 1 times 4/3. That would be 312 times 4 divided by 3. 416. So I multiply those two and divide it by 3, and I get 416. Um, and then what is this? It's pages per hour. Pages per hour. That's it. That's interpret the meaning of the result. That means if you do 312 pages in 3/4 of an hour, you would do 416 pages per hour. Uh, yeah, I'm not going to box anything here because it says explain how to do it. I explained it, and then that's the meaning of the result. Number 12. Number 12 is find k, the constant of proportionality, for the data in the table. Then write an equation for the relationship. Well, k is any y value divided by its x value. So I'll take 66 divided by 22. 66 divided by 22, and that is 3. Um, so our equation then is in the form of y equals kx. And here's k, it's 3. So it's y equals 3x. Done. Oh, that's easy. Finally, an easy question. 13. 13 is create a table that shows a proportional relationship. Do not use an integer for the constant of proportionality. Okay. Okay. So um, I'm going to write this down. So this is going to be number of cookies cost. I have 4 and 7 and 24. And Um, so we need to have this relationship, but I can't do times 2. This can't be 8 or 3 or negative anything because it says do not use an integer. So let's use a fraction. But I'm going to make the fraction 1, I don't know, 1/4. Okay. So the k, the constant of proportionality, will be 1/4. Okay. So I have um, 4 times 1/4. So for this one, it'll be 4 times 1/4, which is just 1. Okay, so that'll be 1. And then for this one, that'll be 7 times 1/4, which is 7/4. Pretty simple. And then the last one right here, that'll be 24 times 1/4, which is 24 over 4, which is 6. So there you go. That's pretty easy. There's 13. And for number 14, I need another sheet of paper. Let's see, let me see if I got one here. Oh, I got one right here. So for 14, I think I might need to just use the page here. A car traveled at a constant speed of 40 miles per hour. Make a graph to show how the distance traveled in miles is related to the time in hours. So 40 miles per hour. So we have 1 hour, 40 miles. So 1 hour, 40 miles. You know what? 40. What I'm thinking is 40. When does 40 become a multiple of of 100, any of the hundreds. So if I have number 14, if I go um, 40 miles per hour, 40 miles per hour times 1 hour, that means you go 40 miles. Um, 40 miles per hour, oops, times 2 hours, that means you go 80 miles. 40 miles per hour times 3 hours, that means you go 120 miles, right? Just 40 times 3. 40 miles per hour times 4 hours, that would be 160 miles. And 40 40 miles per hour times 5 hours, that means you go 200 miles. And I stopped at 200 because I see 40 and 200. Oh, 5 hours right there and 200 miles. I can do that right on my graph here. If you go 5 miles, you go 200. If you go 5 hours, you go 200 miles. So this one right here, I kept going until I got to that point right there. And again, that's from 5 hours is 200 miles. So 5 hours, 200 miles. And if I go 10 hours, I should go 400 miles. So I can even double that. That's what proportional relationships do. You can do that 200, 400, 10. And if I go 0 hours, I should go zero distance. And look at that. Look at that beautiful line that it makes right there. And everything in between. Because what we see here is after 1 hour, it's 40 miles. And is it there? 1 hour is, yeah, that's about 40 right there. Because if I go 100 and this is 50, and then it looks like it kind of hits 40 right there. And if I go 3 hours, that's 100, 3 hours, that's 120 miles. So 3 hours, 120 miles, it looks like those other points show up right there. But it comes off of those ones that are really easy to graph. And you just draw a line through the ones that are really easy to graph, and the other points fill in nicely uh, as long as you're kind of straight and organized and you graphed them correctly. Okay, so we have this one. Use the graph for numbers 15 and 16. So here's our graph. And for 15, what's the constant rate of change for the value in the graph? Well, it comes back to what can I graph easily? And it looks like this dot, this one looks really easy, 60 and 4. It's the y. Remember, these are the y values and these are the x values. So the constant of proportionality, this one will be 60 over 4 because that dot is really easy to graph. So for number 15, our k, the constant of proportionality, which is the same as the rate of change. So k is the same thing as the constant rate of change, uh, which is equal to that 60 over 4. So that's going to be equal to 60 over 4. And 60 divided by 4, you can do it in a calculator. It's 15. Yeah, the $15 per week. Okay, so there it is. And then we have number 16. And we have to use the same graph because it says use it for 15 and 16. Write an equation for someone saving less money per week. Add a line to the graph for this equation. So if they're saving less money per week, then we just need to have a line that goes under this. And so I'll just go easy and I'll go right here. And what is that value? 30. So it'd be 30 divided by 4. I didn't choose the best thing, but um, uh, so write an equation. So 30 over 4. So in this case, k will be 30 divided by 4. And 30 divided by 4, I can't even think right now. 30 divided by 4 is 7.5. Equals 7.5. So our equation, whoa, 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 whoa. Okay, so k is 30 divided by 4, which is 7.5. So our equation is y equals 7.5 times x. There's our equation. Now draw the line, and it really is as easy as it goes through the origin, and it's right there. So, oops, kind of messed up. There, that's it. And then we have our last one. Yay, number 17. An object travels 4/5 miles in 1/3 hour. What is its speed? It's going to be miles per hour. So for 17, it's 4/5 miles in 1/3 of an hour. 1/3 hour. So it's really just 4/5 divided by 1/3. And keep. Change it to multiplication and flip the fraction. And then 4 times 3 is 12. 5 times 1 is 5. And I guess 12 divided by 5, I can't even think right now. 12 divided by 5 is 2.4. 2.4 miles per hour. And there you go. Whew, that was a lot. Well, thanks for watching. I hope this was helpful, and I'll see you next time.